All right, so today's notes are on the laws or properties of logs. I'm going to refer to them as the laws of logs, but your book refers to them as the property of logs or properties of logs, so they could be referred to as either. Our objective is our content objective is to use them to simplify expressions, and our language objective is to use the correct terminology to explain them. So let's jump into what these laws are. So the laws of logs include the product property, quotient property, and power property. And these are actually just a version of your laws of exponents. So if you remember, with our laws of exponents, if I was multiplying two things to the same base, I could add their exponents. Well, this is true with logs too. If I'm adding two logs to the same base, I can multiply their arguments. If I'm multiplying two things in the argument of a log, I can add them as two separate logs. Just have to make sure you have the same base for all of them. So these laws only apply when you have the same base for logs. Quotient property, same thing. If I'm dividing two things in a log, I can subtract them as two separate logs. And power property, if I'm raising a power to a power, I can bring that power to the front and multiply them. So I can multiply the exponent by the log base b of m if it was in the exponent originally. So these are, again, just a version of your laws of exponents, just now with logs, since logs calculate exponents. So since logs are calculating exponents, these same rules that we use with laws of exponents are now going to apply to our laws of logs. So let's see how we could do this or use this to simplify into a single log or expand into multiple logs. So in the example I'm going to do with you first, I want us to simplify or write this as a single log, and then we have log base 4 of 32 minus log base 4 of 2. The first thing you always need to check is that you have the same base on both of your logs, because these properties, again, only apply if you have the same base. So since this works, I have log base 4 of 32 minus log base 4 of 2. I have the same base. I can use my quotient property because they're being subtracted. I can use my quotient property and write them as a single log. So they're going to become log base 4 of 32 over 2. So now I have log base 4 of 32 over 2, which I can simplify as my next step to log base 4 of 16. Now I'm going to evaluate this log. So if you wanted to, you could rewrite it as 4 to the x equals 16. So this is what we practiced yesterday with our logs as inverses notes. So again, you could set this equal to x, use the snail method, or remember base the power equals the argument. Rewrite it as this. I know x would have to be 2. So for this to work, 4 to the 2 equals 16. So I know that 2 would be my answer for log base 4 of 16. All right, so the next couple I want you to do as a quick check, and these ones, just so you're aware, this one has variables in it, so it's not going to simplify to a single number, but this one should simplify to a number. So I want you to try your best to use laws of logs on your own. I'm going to pause it if you need to. I'm going to go over it. So first thing I need to do, since these are being multiplied in front, I'm going to use my power property. So this number in front I can bring up into the exponent. So I'm going to rewrite this as log base 2 of x to the 6th plus log base 2 of y to the 5th. So that's a 6 of the exponent. Sorry if you can't see it. Again, these have the same base, so now I can combine their arguments. So since they're being added, I'm going to multiply them. So I'd have log base 2 of x to the 6th, y to the 5th. And I'm going to put that in parentheses so I remember that that's all in one argument. And that should be all. There's nothing else I can do here that can be simplified. So my single log would be log base 2 of x to the 6th, y to the 5th. So let's go on to the next one. So same idea here. I have a coefficient in front, so I'm going to bring that into the exponent. So I have log base 4 of 6 squared minus log base 4 of 9. Since I'm subtracting these and they have the same base, I'm going to use my quotient property. So I have log base 4 of 6 squared over 9. And now I can simplify that. So I know log base 4 of 36 over 9 will simplify to log base 4 of 4. And again, now I can use my what we practiced last lesson. So 4 to what power will give me 4? I know that will be 1. So again, if you want this off to the side, 4 to what power equals 4? It'd be 4 to the 1 equals 4. So if you can't see that, that's a 1 there. So I know my value for log base 4 of 4 is 1. So my simplified version is just 1. So this whole expression can be simplified to that single number. All right, so we practiced going from an expanded form to a single log or to a simplified form. Now I'm going to flip the page and I want us to try to do the opposite. So now we have a condensed or single log and I want us to expand it into multiple logs. So this one I have a common log or log base 10, so I don't need to write the base. The first thing I'm going to do is separate these since these are being divided, since I'm going to subtract them. So I have log of 4x minus log y, because they are being divided, so I'm using my quotient property to separate them, which I know I need to subtract in order to separate them. Now here they're being multiplied, so I can use my product property. So I have log of 4 plus log of x minus log of y, and that would be my expanded form. So there's nothing further to expand. It's log of 4 plus log of x minus log of y. And since there's no base written, it's assumed to be the common log or log base 10. So the next one we're going to do, we're going to start the same way. So since I'm dividing, I'm going to use my quotient rule. This time I have a log base 9. So I have log base 9 of x to the 4th minus log base 9 of 729. Now I have an exponent here. I'm going to use my power rule to bring that to the front. So I have 4 log base 9 of x, since that exponent was brought to the front, minus log base 9 of 729. So here you might notice that this can be simplified. So you might want to use your powers table to simplify this. But if I do this off to the side for a second, 9 to what power will give me 729? If you use your table, it's actually to the 3rd power. So I can rewrite this whole log base 9 of 729 as just the number 3. So since this whole thing simplifies to 3, even though I'm trying to write expanded form, I can still replace a log with a number or a constant. So my final answer would be 4 log base 9 of x minus 3. And that would be my expanded form of this initial log. All right, so the last thing I want to talk about in this set of notes is the change of base formula. And this is actually very helpful when we're using calculators. So because our calculators only have log base 10 or ln, log base e, the natural log, we're going to have to often use change of base if we want to plug in anything besides base 10 or base e into our calculators. So change of base says that if I have log base b of m, I can rewrite it as log base c of m, the original argument, over log base c of b, the original base. So I can change the base. This c value can be any number that I want. So it could be log base 10. So I could plug in log base 10 into the calculator, which is why this is going to be helpful. Or if I wanted to do another problem a different way, I could change this to any base that I want, as long as my original argument is in the numerator, my original base is in the denominator as the argument. So again, it's log base c of m over log base c of b, where b was the original base, m was the original argument. So again, the way we can use this in our calculator, and I don't have a scientific calculator to show you with right now, but what you would plug into your calculator, if we had log base 5 of 36, you'd plug in log of 36 over log of 5. And again, since I'm not writing any base, it's assumed that it's base 10, which is the common log on your calculator. You could also write ln 36 over ln 5. It doesn't matter what the base is. You could do any other base that you wanted. You could do log base 8, log base 5, log base 3. It doesn't actually matter because at this point you can plug this, or you can simplify the change of base formula works. These two will be helpful when plugged into a calculator. Other bases won't be so helpful. But I can evaluate this on its own once I plug it in, and I get approximately, in either method, I'm going to get the same thing. So I can't show you on the calculator right now, but it's approximately 2.266 or 6 continuing, which ends up being about 2.23. So when you plug this into your calculator in either of these forms, log base 5 of 36, when you plug it in with either of these methods, will give you about 2.23. So that's going to be our answer for these problems, and that's how we can use change of base. So we're going to have a lot of time to practice these, but make sure you write down any questions, comments, or concerns you have on them so we can go over them together in class.